All right, let's try another one. So we're going to integrate the function natural log x over x. And this is not one of our basic forms. There's really no algebra here that we could do to simplify this down. So substitution rule is probably our go-to technique here, precisely because that's our only technique at this point. And so the question is, when we look at this function, how do we choose u? Might not be altogether obvious. How do we choose u? Well, when we have functions and we're not quite sure how to pick, how do we figure out the substitution to use? It helps to break the function apart and look at the different pieces of our function. So let's break this fraction apart, and we're going to write it as natural log x times 1 over x dx. So we have our natural log piece, we have this 1 over x. And so when you have your function kind of written out in these little pieces as a product, you can kind of come up with your choices based on those pieces. And you can, it's almost like a trial and error. If you're not sure, just kind of go through the list. So when we look at this, when we look at these different pieces, there's a few things we could try. We have 1 over x, so I could just try letting u equal the x, the term in the denominator there. That's one possibility. I could also try let u equal the 1 over x. So I have a 1 over x right here. I could let u equal that. It's another possible choice for u. Or I have this natural log x. So maybe I could let u equal natural log x. So I'm just kind of going through and just listing all the possible options. I'm not sure. At this point, I'm not sure how to choose u. So I'm just trying to try different things and see which of them work. So I'm just kind of listing my options here based on what my function has. I could just do u equal x, what's in the denominator. I could let u equal this 1 over x, or I could let u equal this natural log x. So how do we know if it's going to work? Well, we can choose u all we want, but where we can kind of get a feel if that substitution is going to work or not is what happens when we calculate the differential du. And so let's start with u equals x. Well, we never do this substitution. So first of all, we never do this one, because all you're going to do is you're going to have the exact same integral. It's just going to be u in terms of, it's just going to be natural log u over u du. So all you did is just change the u to a, or change the x to a u, but it's literally the same antiderivative problem. So this does not get you anywhere. You're just renaming your variable, and you're at the exact same place you started. So we never do this substitution, u equal to x. All right, so let's suppose we're going to try this one, u equal to 1 over x. So the next step then, once we choose u, is to calculate du. So what's the derivative of 1 over x? Well, that is, if we use power rule, it's negative 1 over x squared dx. So we're calculating the differential just by differentiating this 1 over x. And if you're not sure, you can write it as x to the minus 1, bring down the exponent, subtract 1, and you end up with negative 1 over x squared if you rewrite it back as a fraction. All right, so if we look at our function we're trying to integrate, the terms in what we calculate for our differential, there should be something that looks similar up here. So if we're letting u equal 1 over x, this is already kind of spoken for. And the negative 1 over x squared doesn't show up really in what we have left. We have a natural log x dx. And that doesn't match up too well with this 1 over x squared. So this 1 over x squared is not a close match to the remaining terms. I mean, maybe there's something, if we wanted to get really clever, maybe there's something we could do. But as it is, that the 1 over x squared does not match up too closely with this natural log x. So that's an indication that this is probably not going to work out. This substitution is probably not going to work out. So we're going to cross this one out as well. All right, so, well, we have one more obvious choice here. So let's see what happens. We're going to let u equal natural log x. So we're going to let u equal the natural log term this time. And we can see if it's really looks like it's going to work once we calculate the differential. So we're going to calculate du. What's the derivative of natural log x? Well, that's 1 over x. And then we multiply by dx. And so this is our differential. And if we look, what are our leftover terms? These are our leftover terms. And that is matches up perfectly with what we calculated for du. So this right here is a close match to our remaining terms. So you can tell once you pick u, and if you're not sure, just kind of list out the different pieces of your function and just kind of go through and calculate du. And if when you calculate du, if you can see some similarities here between your leftover terms and what you calculated for du, you're most likely on the right track. And that's what we're seeing with this u equal to natural log x. All right, so this is just, again, maybe you saw this substitution right away when you looked at this, and that's fine. But I'm just kind of going through the thought process. If you're kind of stuck, maybe you get stuck on this one, what might you do to kind of help choose what u could be? All right, so now let's actually go through it. Let's use this substitution. So we had our function rewritten as natural log x times 1 over x dx. We've decided u, so we're choosing u to be the natural log x term, and then we calculated du. What was du? It was the 1 over x times dx. And we're going to fill in our pieces. So the natural log x is our u, the 1 over x dx is our du, and this is a nice perfect match. So we end up with the integral of u du, and that's step 2. So a nice, easy integral to do, which we can get just with power rule. So we add 1 to the exponent, so we get u squared. Take that new exponent, flip it, put it in front, so we end up with a 1/2 in front. And then our plus c. So we've done the integration. And then the last step, convert back to x. So 1/2. And we're just going to switch that u. So instead of a u here, we're going to write that as natural log x squared. So we're just changing this u based on what we decided u should be. U is going to be equal to natural log x. So we're just switching back. And that's step 4. All right, so we're developing some techniques and strategies on how to pick u for our substitution rule. Keep practicing. So let's go through more examples.